Okay, thank you, Jacob. My name is Moni Shahar. I'm the scientific manager of the Tel Aviv University for AI and Data Center for AI and Data Science. And today we have an amazing NLP session. So we have 4 speakers, let me first introduce Professor Yoav Goldberg, who is our first speaker. So Professor Goldberg is a professor in computer science in Bar-Ilan University and the research director in Allen Institute for the AI that was founded in Israel in 2019, I think. Prior to that, Yoav was a postdoc in Google Research. His research interests include language understanding, technologies with the real-world application. He's combining symbolic and neural representation, uncovering latent information in text, syntactic and semantic processing, and he's working on interpretability and understanding of deep learning models. He's also the author of a great book on deep learning techniques for natural language processing, who I personally own. And Yoav will talk today on user-centered NLP interfaces, abstraction, and some missing pieces. So please, Yoav, the stage is yours.
Hello. Let me just share the screen. Okay, so should I start now or take some time? Okay, so hello all, and welcome. This is my talk on user-centered NLP. And then you may ask, what is user-centered in AI or NLP? And there are many different answers for these questions. And many different people give different answers, and I can give 3 of them. So it can be AI for the benefit of people. It can be AI which is explainable, transparent, trustworthy, and so on. It can be AI which is controllable, maybe. And indeed, my lab at Bar-Ilan works on all of these aspects and some others as well. So Alon is working, Amit is working on NLP for sign languages. Alon is working on user-centered, explainable, and trustworthy AI. And he asks foundational questions such as, what does it mean to understand the model? What does it mean to trust a model? And how do users perceive an explanation? So his take on this question is even more centered around users than most people do in this area. And then Shauli is working on controllable AI, asking how can we interpret and change as users? How can we change vector representation? How can we remove information from the representation? How can we add information? And how can we uncover and reduce biases in models using these techniques for the benefit of all? So these are all potential answers for what is user-centered AI. But these are all subjects for different talks. I will not talk about this today. Today, I'll use a 4th definition, which is empowering users to achieve their own goals with AI or with NLP. And you may ask, isn't this happening already? AI is so cool, it's so prevalent, we have these great frameworks. And I will say that no, not really. So let me now talk about what is NLP today. So NLP today basically looks like that. We have many colorful models, and with neural networks and pre-trained language models and data sets, we pretty much revolutionized the field. And we, as NLP people, can now build some amazing things, but we can do it if we have the data, and of course, if we have the accompanying data scientist to actually work with this data, right? So strong NLP today requires both data and expertise to use, and I would argue that also non-state-of-the-art NLP requires data and expertise to use. So it's really not cheap, right? This condition works very well for ML consultants and experts for hire. They get paid a lot. It works very well for companies because they can build products and they can have some lead because no one else can do it. And it's good for common NLP tasks that are needed by many people. Okay, so if you look at the tasks landscape in NLP, you can say it looks like that. There is a long tail phenomena. So on the x-axis, you have different tasks, and on the y, you have the number of people who care about the task, or maybe profitability of the task. And if you look at the head tasks, there are many things like ad prediction that's very profitable. If you want to maybe extract from text, merger and acquisition, many people care about that. You can have maybe gene plotting interaction, maybe people care about that. Identify spans about locations or diseases, also kind of popular, drug interaction, and so on. There are many tasks at the head, and you can build a company around these. There are companies around most of these, or some academic project. But then there are also the tail tasks, right? The tasks that only few people care about, and they may look like that. So I am kind of looking at sciences now, but there are also other fields. And you may ask which polymers can be injected, or what are typical causes of bacteremia, or what are surgical tools that are associated with cancer therapies, or what are the chromosome counts for different fungi, and so on. Right, and these, beside being niche tasks, if you can also see, they have these items here, which are also kind of niche entity types. So you have to identify these spans. There is no ready-made NER, and there is really no incentive to make one. And working on these is much harder. Basically, the current way we do AI or learning is not effective for the tail because you have to create data for each task, and it's really not worthwhile, right? There is a lot of effort here, and you cannot build a company or a project around this, right? It's just not worth the effort. Let me skip this. But the tail, I will argue, is very, very important for many users, right? So there are some tasks that like everyone needs, but then different users need different things, and these users need maybe kind of specialized, but each of them is important for someone, and it will be good to empower them to actually achieve these goals. So let's look at an example of what's happening today, right? So let's take of a problem such as what are the drug treatments for bacteremia, which is some condition which is quite common, not very common, right? Many people didn't even hear about it. So how would a domain expert, say a doctor or a researcher in this field, go about this today? So one thing they can do is basically search, right? That's the kind of, you want to learn something, you search. So you can ask Google, you can ask either what are the treatment, or just say in 2 words, bacteremia and treatment. And you get, as the first result, something which is kind of promising, right? Bacteremia causes symptoms and treatment from Healthline. So you click on that and you get this explanation. It looks good, and you learn that the treatment for bacteremia is antibiotics. And this is useful for the layperson, but it's really not useful for experts because they just want to know which antibiotics, right? Not only antibiotics. So they go to a different search engine, say Google Scholar. They get a bunch of papers, and they may look at the list, or they go to a more specialized engine like PubMed, right, of all of the kind of medical literature, biomedical. And then if you look at the third result, you find this survey, and in this survey you have this table, and this table has a nice list of different antibiotics which are administered for listeriosis, which is a kind of which bacteremia is a kind of. Right, so luckily here someone did this research for us, but then you may ask, is it up to date? Are these and also these are all treatment which are recommended, but what else was tried? Are there new treatments, maybe that are not yet kind of popular, but maybe in the future, and so on. So this is a good but partial answer. And of course, other possible solution is just, do NLP. So build an IE system to kind of extract information. Then you may ask, okay, but who will develop this system? Right? Who will develop the system of causes of bacteremia treatments? And would you really invest as a researcher 5 months at the minimum to get an answer, right? You need to label data, you need to pass it to the ML experts, you have to do a few rounds. This is really high effort for an answer. And then there are QA systems, but they don't really work well enough yet, even though they're quite amazing, and they are not supporting this type of question well yet. And speed is also an issue. So our take on this problem is to do it yourself, user-centered NLP. And our hypothesis is that by empowering domain experts to use advanced NLP capabilities on their own, we can achieve amazing results. And the goal is basically to empower SMEs to work effectively and creatively with large text collection and then see what they create, right? So we want to build an enabling tool and a framework. And to do this, we need to answer several questions. For example, what are the needed NLP building blocks for this? What are the right abstraction for exposing to the users? How can we support it with the right UX and software? And how can we put the user in control? And this is an ongoing project at AI2 and Bar-Ilan, where different institutions are looking at like different aspects of it. So more basic research at Bar-Ilan and more engineering and applied research at AI2. And this work is really a work of many, many people. You can see them here. So really, they did most of it, not me. And what I'll present is a system which is using something that we developed, which we called extractive search, and the system is called Spike. It's available online. As you can see, it has many different data sets, and it looks like that. It's a search-based system, right? So we have a search-based UX, which is tailored specifically to support queries that require to aggregate knowledge from different documents. It's targeted at domain experts, and it requires them to learn a new search language for this. So it's not questions yet, it's queries, but they are very powerful queries. Okay, and the main components of this framework is that it works at the sentence level. So you basically search for sentences or even below that, but you also retain a connection to the overall document structure. We pre-process the data with some advanced NLP, so linguistic annotation, and then we enrich the queries with what we call capture slots, and that's the main innovation that I think was not seen before. So the idea here is that you match sentences that satisfy the query, and then you that search, and then you mark and aggregate over the capture slots. So let me give you an example. So we take the query from before, bacteremia and treatment, but then because we have annotation, we can also add this to the query. And this here means we want the results to have bacteremia, treatment, and also an entity of type chemical, right? And we can do it because we have NER. And then we want all of the items to appear in the same sentence. And we can also be like fancy with like lyrics or lemmas. Let's keep it aside. And then if we run the query, we get this. So you get each result is a sentence with a link to the document. And you can see here many different chemicals that we also found. And I promised you aggregations, and these are empty yet. So what we have to do here is basically add this colon to the term to indicate a capture. And once we do that, now we see that all of the kind of chemicals are in red, okay? But also we see here on the side that we aggregate and count them. So now we have, based on all of our over 2,500 sentence matches for this query, we see the counts for different chemicals, which are basically different antibiotics. Right, so we can see first that we have some NER mistakes. So NER is not perfect, and we often see mistakes, but we can ignore them because all of the others are actually chemicals, and this list goes on for a while, and there are more there. If you look at the list from the table, we can see that we kind of recover most of the table, and the rest are down the list. But all of the other ones here are basically not in the list. So we have new treatments, which maybe suspect treatments that we were not aware of. And now if we want to say, okay, is streptomycin really a treatment? We can basically interactively choose it and then look at the evidence and read and see if it's really a treatment or not. And we can do it for other as well. And we can also refine the query based on our domain knowledge and so on. So I hope I convince you that captures are a very powerful addition to search. And now let's see some other example therapies for lymphoma. This has a different search strategy. Okay, so here we start with the word lymphoma and therapy, and we want both of them to appear. But now we want to capture the word therapy and also expand it to its linguistic phrase, which is something that we can also do. And now what we get is basically a list of phrases that contain the word therapy together in the same sentence with lymphoma, and it gives us a very nice list of therapies. So you have radiation therapy and high dose therapy and salvage therapy and rituximab therapy, and so on, right? And each one of them, you can kind of click and see the papers and see the discussion. You can scroll down the list and see more. Cytotoxic therapy, intensive therapy, antiviral therapy, monoclonal antibody therapy, and so on. And this goes on and on. And really, this is a goldmine for a doctor or a researcher getting into a new field. It wasn't something that was available to them before, but now it takes 2 minutes to basically run the search and get the answers, and they can refine it later. And this is only kind of scratching the surface of what Spike's queries can do. We try to make them kind of similar to like SQL for text. It's not that easy, of course, but we are getting there slowly. And I will not kind of go into more details now because of time, but that's the kind of direction, and I hope you have a taste of what we can do. And Spike today basically is based on search UX innovation with very strong indexing capabilities that we developed, and some symbolic NLP like post tags and lemmas and NER and dependency graph and phrases and word senses. We also have word similarity to word2vec, and we have like lists and taxonomies. And it's basically kind of basic NLP capabilities, or what kind of used to be state of the art, and now it's kind of basic with all of kind of non-neural like fancy stuff. But these components play nicely with each other. They are well integrated, they are composable, they are flexible, and really people can achieve nice things with them. So here are some like stories of what people have done. So doctors in some hospitals in Israel who are working with the system, I will not tell you which one until the kind of paper is ready and like what was the condition, but in a previous study, they tracked changes in treatment plans for some conditions over time, and they wanted to replicate it and to extend it with our system. But using our system, they soon discovered that their initial method was wrong, and that they kind of somehow refuted their own original study, which is bad for them, but good for science, and they are now working on a much more robust study with different conclusions. Also, while working on that, they discovered new etymologies, new causes for that condition that we are not aware of. And these are basically experts working on this domain, right? So they kind of discovered new causes for this condition, and they now added those to the protocol in the hospital when they try to kind of diagnose. So that's something new, which really made an effect on the world. And now they are working to adapt this to other medical conditions. So that's pretty cool. The second story is about Yossi Shammai's lab at the Technion, and he is a heavy spike user. And one thing he asked is what sizes of drug combinations are reported for treating different cancer types. And that's a question which is very hard to answer, but using Spike, he managed to basically create this very nice heat map of, on one side, cancer types, and then combination size. And he gets some insights from that, which he's now using to guide his lab research. Some other thing that he did is this idea of ad hoc knowledge-based construction. So you can start by focusing on some entity types that you care about, like biomaterials, drugs, cancer, legion, cell types. Then you define relation between them. Then you extract these into this graph of relation from the text, which is very hard to read, but if you kind of zoom in on a pass, you can get to things like that, which basically allows you to go from drug to a cancer and so on, and refine your hypothesis. And it's all based on basically data and anchor to the literature, and they can do it also for different types of graphs, and they do. And this takes a while to kind of develop, but after a week they get something working, and it's very useful. So empowering users work, and they find surprising uses, and they build amazing things. There are some lessons learned, which I will kind of skip now. Some tasks are hard, I will also skip that. I would say that we learned that human expertise plus tools is better, I think, than AI automation, and human expertise plus tools plus AI can be even better than either human or AI alone, and that's where we are going. So how can we integrate AI in this? There are the obvious candidates like active learning, human in the loop, and so on. This is kind of boring, and it's really not user-centered. It's like company-centered, so we don't want to do that. It's also kind of boring. We have other ideas, how we can integrate model QA models, dense retrieval, interactive voice suggestions, and so on. And we want to have better kind of symbolic NLP and better foundation NLP tasks. One of them is this paper, which I will not talk about, but it's one of my favorites this year, which we kind of did. I think it's a very nice new foundation task. And we also have other supporting tasks that we are working on. And to summarize, user-centered NLP aims to put the power in the hand of users. Good abstractions go a long way in doing that. Domain knowledge is more important than tweaking neural architectures, and there are many ways to integrate AI into this, but they may not be the immediate suspects. And if you're interested, please come work with us. We need both research and engineering expertise, because engineering is a very big part of this. So thank you.
Thank you, Yoav. It was very interesting, of course. And I really love the fact that most of the interesting problems in the world are actually tail problems. That is nice. So let's switch to some questions from the audience. Is Spike only available for medical sciences, like the PubMed or that?
So we can potentially index every corpora, currently only in English. We have PubMed, and we have other corpora such as US patents and Wikipedia and so on. We may add other ones if it's kind of head corpus enough. And we also support users uploading their own medium size data set. So if you have something which is like up to, say, 100 megabytes of text, we can also support that. Just like contact us, and we'll show you how to upload it. We are working also with, say, people from political science who are also working on it now for their own needs.
How about mathematical sciences, because it's a different language?
So mathematics are harder because of all the equations, and we don't do currently equations or even tables very good yet. We are focusing on text for now, and it's hard enough. But at some point, yeah, someone should do equations.
And so is it publicly available? If I want to index, I don't know, some chemical data set, some chemical corpora, is it publicly available?
Yeah, it's available online. There was a URL before. I can try to go back to it. Yeah, people can copy the URL from the bottom of the many slides from the bottom of the screen. Here. Okay, yeah, so it is available online. For indexing a new data, there is a different link, but email me and I'll get you the details.
Mm-hmm. And it's only available in English, as you said, because some people asked us about this. And I have another question. Does this enrichment for the query, these SQL-like queries, is it based on domain knowledge, or is it done in an automatic way?
So basically, we don't do any automatic query enrichment without user involvement. So the user has to specify what they want to find, right? And we are now working on ways to maybe suggest to them other queries that they can work. This is still very experimental and doesn't work very well yet, but we hope to get something better during the kind of coming year. But yeah, it really depends on the user knowing what to search for. But we found that with some practice, not immediately, but with some practice, people can do very strong things with it. So it's basically, like in SQL, where you write SQL, you don't kind of get automatic suggestions. You really need to kind of know what you're looking for. But once you do it, you get very strong kind of results. Also with Excel, this is kind of the kind of similar spirit. You have to specify what you want, but we get you tools to actually get there.
So the role of the user is the generator for the queries. And do you also extract some feedback from the user, like regular search engines?
Currently, no. And also, but like unlike different search engines, we do not rank results, and we do not show you the kind of 10 best results. We get everything in the corpus. Okay, so that's a kind of big difference. We are not looking for the best kind of result. We are getting from like small snippets from everything, and then you can kind of browse this list and see what interests you.